heavier the foot, the more conscious you're going to be of the prosthesis, and the less natural it's going to feel as compared to your sound limb. Also, with less weight, you're reducing energy consumption, which is crucial during an endurance event. You want to have a non-mechanical design to reduce failure rate, and the most popular material used is carbon fiber epoxy composite materials, because they have a very high stiffness, a high strength to weight ratio, and their energy storage capacity is much higher as compared to metals. Next slide. So you're going to see two different designs out there with runners. You're going to have a C-shaped design, which the prosthetic foot mounts to the distal end of the stump, and it eliminates the heel, which forces the center of gravity forward, which flexes the foot and then propels the runner forward. They're very lightweight, some as little as 11.9 ounces, which is about as much as a shoe. They also have a J-shaped design, which if you have a transtibial amputee that has a very a very long residual limb, their foot clearance is going to be an issue with the C-shaped design. So they have the J-shaped design that mounts to the posterior side of the external socket wall. And you can see this in the next slide. You have the C-shape on the left, which mounts to the base, the bottom of the shank, and then you have the J-shape as seen there on the right, which mounts to the back side of the prosthetic wall. And that man on the right, they referred to him as the Blade Runner. He was the guy who was banned from competing in the Olympics, even though he was fast enough and able to compete against able-bodied runners. Next slide. So moving on to cycling-specific prosthesis design. Starting with the socket, the suction suspension is still the most popular used design. Because cycling requires a greater knee range of motion as compared to running, which is going to lead to greater knee flexion, you're going to have material bunching, which leads to skin irritation. So trim lines of the socket wall are adjusted and reduced because of this. The athlete has the option to use two separate sockets, one for running and one for cycling, or they can have one socket that remains on at all times that has a balance of the needs for both sports. For transfemoral athletes, they will generally have a lower medial wall on the socket to eliminate contact with the bicycle seat, and they can afford to lower the medial wall as compared to a running prosthesis because stability is not nearly as crucial in cycling because there is no impact. Next slide. So with the knee design, with knee stability being less of a concern in cycling, you can use a polycentric knee in free swinging mode. It allows for a more symmetrical movement of the lower legs. The only problem with it is you cannot pedal while standing out of the saddle or the seat. But generally this isn't a problem because it's extremely difficult for athletes with prosthesis to pedal when standing out of the saddle. And they still do have the option to use resistance control. Usually with a flick of the switch they can have hydraulic damping as opposed to being in free swinging mode. And this picture here is of Rudy Garcia Tolson, who is I don't know if you can see his other leg there, but he is a transfemoral amputee on both sides. So he's got two prosthetic legs from basically the mid-femur down. I mean, he was the first transfemoral athlete to compete in an Ironman event and complete it. Next slide. So the cycling ankle-foot design, with a leg amputation you lack the ankle stabilizing muscles, so you require a more rigid ankle construct. With energy storing feet that are used for running, they're very flexible and you just don't have that rigid ankle. So they move to things like the Osser Veriflex, which if you look closely in that previous picture, that foot he had there that was more rigid and didn't look like a running foot was an Osser Veriflex. You can also have a custom-made aluminum or carbon fiber pylon that attaches directly to the metal pedal, and you can see that in the picture here. There's no foot or ankle on that cyclist. The only problem with this is, what if you need to dismount the bike during competition or training? If you have a flat tire, or if you crash or something, then you're stuck walking on a peg leg basically. Next slide. So the pedal system's used to attach the prosthesis to the pedal and the bike. You have several options. You can have studded pedals in a tennis shoe. You can have toe clips, which are basically like stirrups, or you can have a clipless pedal system, which is seen here to the right. You have the pedal on top there, which will mount to the crank arm of the bike, and then you have the cleat below it, which will mount to the bottom of your prosthetic foot, and that engages with the pedal and creates a secure connection. The optimal design is a double-sided clipless pedal. It provides very secure attachment for optimal power transfer, and it does not matter which orientation the pedal's in, you can clip into either side of that pedal. And the cleat placement on the prosthetic foot should center the pylon over the pedal for optimal power transfer. Next slide. Now, in any sanctioned triathlon, whether it's by the ITU, which is the International Triathlon Union, or the WTC or the USAT, you're not allowed to use a prosthesis during the swim. Once you exit the water, you are allowed to use a prosthesis to navigate your way to your bike. And if you decide not to use a prosthesis, you can hop, or you can use crutches like the guy here shown to the right. And you're also allowed to receive assistance from a volunteer. For training, prosthesis are recommended because they can allow you to enter and exit the water easily, and they strengthen your residual limb. However, you need to keep in mind that they need to be waterproof and salt resistant if you're going to be doing ocean swimming of any kind. And they need to have some type of buoyancy control, which usually involves water being allowed to enter the prosthesis so that the prosthesis isn't weighing you down and having you sink to the bottom. Next slide. So here's a prosthetic ankle foot design for swimming here. Picture here is the Freedom Innovations Freestyle Swim. They lock in a neutral position for walking, or they lock in a plantar flex position, usually about 70 degrees of plantar flexion. And this is, for when you're in the water swimming. So your toes are pointed like you'd see with, an intact limb. Next slide. For a transfemoral amputee who wants to use a prosthetic knee, they need to be completely waterproof, and one of the only designs out there right now that can accomplish this is the Ollie 802 nylon knee with hydraulic damping, and that's seen there to the right. Next slide. You can also have fin attachments, which help improve propulsion in the water, and they allow you to